share my screen. Okay. Good evening to all of you. Welcome back to Machine Learning Stack. In the previous week, we have learned about the different type of regression evaluation matrices. Today, we are going to talk about the classification matrix, which we use to check the model performance of the classification problems. Welcome to week 7, lecture 1, Data Science in Python and Machine Learning, Coding Dojo. Please type your answers in the chat. Which regression metric penalizes large errors but returns a score in the same unit as the target? Please write your answers in the chat. Okay, good. Yep. Yes, the RMSE is the one which penalize the large errors, and it will also come in the same unit as the target one. Announcements. Assignments due this week by Friday at 9 a.m. PST. Assignments pending are classification metric, logistic random forest or KNN, project 2, part 1. Belt exam for stack 2. This is going to be start from the July 8th and 10th. So you please set aside at least 8 hours for the belt exam, because it's going to be like long this exam. Must have attended 80% of the classes. Must have submitted all assignments from weeks 1 and 2. Must have submitted all resubmits from week 1. So the students who did not resubmit the assignments from week 1, please resubmit those assignments to be eligible for the code of belt exam. Week 3 material will be on the exam. So if you go to the LP, if you want to do the practice before the exam, here we have, go to this link, preparation for belt exam. So this is, it is explaining about the belt exam process, and it has a one mock test. This is same format which you are going to get in the real exam with the different data set. So you can go through this and practice with this one. Belt exam on Learn platform, as we have seen. Any questions from the announcements? All right. Data set selection for project 2. Look for a data that has a target column to predict with the target that is likely predictable using available features. Is not overly complex or overly simple. It may have 6 to 15 columns that you mostly understand and can explain. 1,000 to 100,000 rows with not too much missing data, less than 10% if there is a missing data, is something you are interested in. So be ready to answer why did this project interest you. So whenever you give the data set, like you should know why you are choosing, and these these are the things which you need to take care while choosing the data set. Your data set should not be based on time series, because we are not covering in this cohort. In upcoming stack, we will cover the time series algorithms. Try Googling the data sets for machine learning and look through the articles, sources, list repositories. If you want to look for a good data set, then you can Google top 5 or top 10 best data sets links. So it will show you the best resources of the website which contains a different data sets. Like you can go to the UCI and Data World. There are a lot of websites which is available, and you can choose the data sets from there. If you have any questions, please feel free to ask. Any questions about the data set selection? It is also recommended you choose 2 data sets. If one data set is rejected, so you can use the other one. So you can keep the one data set as a backup. This is few best practices. Always print each statement if you want to debug your error. Because I found many students found the errors while they are coding using the notebook, and they are trying to debug it, why this is coming. So if you have any confusion in that, if you want to debug the error yourself, it's a best practice, best coding practice. Always try to print the result from where you see the error may come. So try the print the each statement. It will show you the output and you will come to know where the error is. So this is best practice, and try to interpret the each method used in your notebook. This is the best way to learn about the coding as well as your concepts. It will be more clear if you are trying to interpret the each method and each functions you are using during analysis and why you are applying this model, and also the evaluation matrices you are using for that. Try to always write code yourself. Even if you are looking at one notebook, typing the code in other, this will also help, but always try to write the code with your hand. Always avoid copy and paste. Use the pen pencil and build the workflow before starting the code. So when you start to do your practice core exercises to start the code, always make your habit first understand the flow of the work. What is your goal, what you want to do, make with the arrow. First I need to import the libraries, then I will do this. So make a rough sketch. It will really help you to write down, follow the proper your workflow for your exercise. Learning goals. At the end of this class, you will be able to read a confusion matrix to understand what kinds of mistakes your model is making. Determine which classification matrix is most important for a given business problem. Evaluate a classification model in sklearn. So this is our today's goal. We will start with the classification matrices. Classification evaluation matrix is, first of all, we will learn about what is confusion matrix, and then what is accuracy, precision. We also call it false positive rate. Recall, false negative rate. Then we will learn about F1 scores. Classification evaluation matrices. So there are 2 types of classification. First of all is the binary classification, in which we will predict one of 2 classes, like positive or negative. In this, we have only 2 classes, not more than that. That's why we call it binary classification. If we give an example of here, the disease, we want to know whether the patient has cancer or not. So this belongs to binary classification. Multi-class classification. Predict one of 3 or more classes. So we will predict only one class out of the 3. So this means which class is positive. This is the multi-class classification. We can take an example here. Like if you have 3 type of images, dog, cat, and bear, and you want to know which one is like the dog. So you are going to choose one class as a positive. This is a multi-class classification. Any questions about this?
Sorry, Nirja, can you just go over that last part again? So when there's more than 2 classes, you only assign a 1 to the one that you want to predict for?
Yes, like if you have a 3 classes, when we are talking about the evaluation metric, we want to know which class is going to be one, like positively we are taking the output. I want to take this class.
Okay, and then all the others that you don't want to predict for just get 0.
Yes.
Okay,
because here, because here is a no 0 and 1. This is more than 2 classes.
Got it. So you would never assign like if there's 3 different values in the feature, you would never do like a 0, 1, 2. It would just be zeros or ones being what you want to predict for.
Like if you have a 0, 1, 2, right? So we are going to predict which class belong to 0, 1, and 2. But when we apply, like we are checking the model performance, you are going to learn it now in upcoming slides. Then you will understand it more. Okay.
Okay.
Classification evaluation matrix. We are going to start with the binary classification matrix. So examples are, is email spam or not? Is it a cat or dog? Does customer have income over $1,000? Yes or no? Is a machine going to fail soon? Yes or no? Will a customer pay back a loan? Yes or no? So these are all examples belong to your binary classification, because we are talking about here only 2 classes and we are interested only in the positive class. This is what we want to like learn today, how you can check your model is performing. Classification errors versus regression error. Regression. What is the difference between the prediction and the true value? That is called regression error. What is the classification error? Is the prediction the same as the true class? So like if your actual value is 1, your machine is also predicting this is 1. That is, this is a classification, but if you are saying your actual value is 1 and your machine is saying 0, this is become classification error. Any questions about this? Okay. So before moving ahead in a detail, first of all, we will take a look at confusion matrix. What is this? What is confusion matrix? Confusion matrix is a visualization form which tell you the errors in your algorithm, how your algorithm performing, what type of error. So this is the very good, like the confusion matrix, it is explaining very well how your each category is behaving, like how your model is working. If you look at this diagram, diagonally, these numbers are, we say,
We're getting some feedback. Can you, everybody mute, make sure they're muted right now? Thanks, guys.
okay. So this is the diagram of confusion matrix. We also call it error matrix. This will tell you like how your model is performing, and if there is any classification errors, this will show you very clear, belong to each category. If you look at the x-axis, this is your predicted labels. This is negative, this is positive. If you look at on the y-axis, this is actual labels. This is your negative, this is positive. And this diagonally, if we look at these, we can say this is your good score, which we want to look at it, like how my model is performing. And this is we call the bad numbers. Like we always want to decrease these numbers. And we always want to like have a good numbers for this one. So goal of the confusion matrix is always reduce your false positive error and false negative error. So how we denote it? The TN known as a true negative and your FP known as a false positive. For FN known as a false negative error and TP known as a true positive. We also call the false positive type 1 error. And we also call the false negative type 2 errors. So this is just the layout of your confusion matrix. Any questions about this? So in this, when you look at in this diagram, if your actual input is 1 and your machine says it's 1, so this means this is the true positive. What is actual? My machine is saying the same thing. So, but if your actual input is 0, but still your machine says 1, so this is going to be your false positive. This is going to be for type 1 error. And if we look at it another way, like if your machine says actual value is, if we say it's a 0 and my machine is also saying 0, then this is true negative. And if my machine, I'm giving the 0, my machine says, no, it's a 1, then it says false negative error. This is going to be opposite. So our goal is always, whenever you look at these values, your goal is to reduce this. And it depend upon, it will vary according to use cases, what kind of domain you have, what kind of data set you have, which error is important for you, or maybe sometimes you both need to reduce. Sometimes you need to only reduce the one. This is we will discuss in few minutes. Any questions about this? Okay. So now we will give like a little more definition. What is the meaning of true positive, which I have explained earlier here. This is just an example with these numbers. True positive means when your actual value, actual label was 1 and your machine is also predicting 1. We call it true positive. False positive, when your actual value label was 0 and your machine is saying, no, it's a 1. So we call it false positive. When you have a false negative, if your actual label is 1, your predicted value, your machine is saying, no, it's a 0. This is called false negative. True negative, when your actual label is 0 and your machine is also saying 0. That is, say, true negative. Any questions about this? All right. Okay. Now we will have a basic understanding what is confusion matrix, what is TP, TN, FP, FN. Now we will learn how first method to evaluate your classification model, how we do that. If you look at this picture, here earlier, as we have discussed, these are the good numbers, which we always want to keep. And these are the bad numbers. If I give an example to you here, I have a records of thousands. I have 1,000 records. If your class, your machine predicted 600 your records as a true positive, I was giving class 1 600 records and my machine is also predicting 1. So this is going to be TP value 600. And if it says 0 and it is predicting true negative, this is 400. So how you will calculate the accuracy for your classification model? The formula for accuracy is true negative plus true positive divided by the total number of all matrix values. This will help you to find the percent of correct choices out of the total number of the predictions. So that's why we are going to divide it with the total numbers, and it will give you the percentage of the correct choices out of the total numbers, total predictions. So this is called accuracy. If you look at this again, this is your actual input and your machine is also saying this is 1. So this is true positive cases. And this is true negative. If your actual label is 0, your machine is also saying it's a 0, it's going to be true negative. So this is the way how we calculate the accuracy. In this, the most important point is when we are applying the evaluation matrix in the classification model, we need to take care of the balance of the each class. This is the most important here. Any questions about the accuracy? Okay. So now we will talk about the pros of the accuracy. This is simple and easy to understand because you have only one number which will tell you how your model is performing. Like if it is giving you 0.96 accuracy, this means your model is working is able to predict 96% positive values from your model. One number describe all classes because we have only one number in this. Works the same with binary or multi-class. It works in the same way with the multi-class as well. This is we will discuss after completing this topic. Cons. A bad model can have a high accuracy. How the bad model can have a high accuracy? This is, I will give you the example in upcoming slide. Does not tell the whole story. It does not tell the whole story because we have only the single number. We don't know like in these how many like the classes numbers we are getting, like for the true positive, true negative, that one is misleading when class is not balanced. This is most important point in case of accuracy. So these, a bad model can have a high accuracy, is misleading when class is not balanced. Look at this picture. If you look at these, I have two classes here, 0 and 1. If you look at this, class 0 have how many records? 212. And how many records of one class have? 52. This is imbalanced class, imbalanced data set. So if you apply the accuracy on these, it will also give you the good accuracy. Why? Because your model become biased towards your 0 category. So you still get the a good accuracy. If you look at these, it is saying 80% it predicted the 0 class, 19% it belongs to 1. So your accuracy is depend upon the class balance. In this is very important. Like when you apply the accuracy, you need to take care of the balancing of the classes. This is an example. A simple baseline model predicts 0 for every row in the test set. If you look at these, my machine predicted every value in the test set 0. Look at the actual values. Here all are a 0 except 1. So this means if I apply the accuracy on these, my model is saying this is 90% accuracy. We say, wow, I got a 90% accuracy. But this is not going to work in other, like the domain, some domains. Like for example, if you are detecting is the patient have a cancer or not, in that case, what will happen? This model is going to be fail, because if you look at this value, this means patient has a cancer, but my machine says no. So what will happen to that patient? He will not get a further treatment. It is going to be very dangerous for him or her. So in this case, our accuracy evaluation metric is going to be fail. So it depends vary on domain and case to case use cases. You need to apply all evaluation matrices according to your requirement and then see the result. We know the accuracy is the easiest way to check the performance of the model, but we need to deeply understand the over goal of the model. While it is tempting to be excited about an overall accuracy of the 90%, we didn't really achieve anything with our baseline. If we were trying to identify people who had a disease, we will fail, as I have given the example of cancer. If we were trying to identify spam emails, we fail. Because if I connect it again here, my actual value is email is spam, right? But here it's a not spam, sorry. And here I'm saying my email is spam, but my machine is still saying it's not spam. It may be the most important mail, urgent email, which we will miss. So in this case, our model will fail. If we were trying to identify fraudulent credit card purchase, we failed. There is more to evaluate classification model than just a accuracy. So we have another methods as well, apart from the accuracy, which will help you to check the performance of the model and help you to decide which one is a good. And there is absolutely more to making prediction than just over baseline.
Yeah, in the example you mentioned, in this example, so the prediction was 0, actual was 0. So in 90%, it did make the right, correct.
Yes.
So what is the problem then with this?
Problem is this is may correct for this one. It depend upon the domain, right? If I take an example of here, like a very simple example, let's say, we can take an example here. No, not disease. Like if you want, sorry.
Are you saying that this 90% accuracy is incorrect? Is that number incorrect?
No, this is correct according to this data, right? This is not incorrect. I'm saying, like, for example, if you are like classifying the images, right? You have a 2 images, cat and dog, right? You are giving the input of these, right? This is like you are saying, this is not cat. Your machine is also saying, yes, this is not cat, right? Here you are saying, this is cat, but your machine is predicting yes, saying, no, this is not cat. So it is not going to affect your any problem like which can be converted into disaster or maybe harm something, right? But if I take the same example for other domain, other use cases, like for say disease, right? So in that case, what will happen? If I am telling my machine, patient does not have a cancer. My machine says, yes, he does not have a cancer. So there is a no worry about it because patient do not need that further treatment. He is fine. But if I'm telling my machine, like he has a cancer, my model is so biased towards the negative value. He's saying, no, he does not have a cancer. So what will happen what will happen with this person? He will not get the further treatment. This is going to be very dangerous model, right? Because the patients will not get the treatment who have a cancer.
This is a lot like the R2 of our regression models, where it's like this compared to other models is like, yeah, that's good, but that's not actually taking into account the information.
Yes, Like in this, now in the regression, what we do, like we check the like MAE, MSE, RMSE, then R2 to comparison the different models. Here we need to look at the values which we want, right? We need to decrease the false negative, these two errors here. We need to decrease these two errors in the classification problem. We want these values good. So these values depend like domain to domain, like what use case you have. Like Rod is asking about this, why this model is not good. Now, if I was connecting it with the simple images, then it is not affecting. This is not going to be dangerous. But if I'm connecting the same model, applying to the disease one domain use case, then it can like very harmful or dangerous for the patients. So that's why this model is not good in that case.
Yeah, just like anything in machine learning, the problem defines the solution. You know, it doesn't like you. Obviously, you want better accuracy across the board, but in some cases, it won't matter. You're like, I can only get 60 R2 in this regression problem. That's fine. But in classifications where people's lives are at stake, we want to make sure that we're absolutely making sure that we have the right model. Everything depends on the problem.
Because we want the same output as the target value, right?
Okay.
Is there any questions? Okay. So now, yes, please. Yes, Jason.
Yeah, so I'm kind of wondering, so you really just want like the model to, so if the person doesn't have the disease, but you're predicting it is, it's better to have those types of errors than to have an error where the person actually has a disease and you're saying it doesn't. Right?
Right.
So you're really looking for like, was it type 2, more type 2 errors versus type 1 errors?
Yes, because this is the only one method. This is the easiest method. We are checking the performance of the model. So we will move ahead to the next one, that is over precision one.
Okay, so like say if like the accuracy would the accuracy be 90%, but you're still hitting like 100% identifying of
Yes.
the target,
Yes.
then, right? Yeah.
Right. Right. Now we will talk about the next evaluation matrix, that is a recall one. So what is a recall? How many total predicted positive values out of the total actual positive values? This is called the recall. So this means how many total actual positive value you have, and your machine is predicting the how many total positive value. This is called recall. And if you look at these, what is the formula of the recall? We also the formula for the recall is true positive divided by TP plus false negative. This is true positive, false negative. So what is a false negative? Your actual label was 1, but your machine is saying 0 predicted. So this is going to be false negative. If we take an example here, again, the cancer, no cancer. So in this case, what will happen? If I am telling my machine the patient have a cancer, but my machine says no, he does not have a cancer, then what will happen? The false negative, your numbers is going to be increased. So my goal is to reduce this error. I want to reduce this one because this is going to be more expensive. So for these, what I will do, I will apply this recall evaluation metric to come to know the percentage of total predicted positive value out of the total actual positive value. We also call it sensitivity as well. Any questions about the recall? All right. Recall, also called the sensitivity. Prawns. Penalize a false negative, rewards finding positive class. So false negative is this one. We want to reduce this error. So it will penalize these errors. Tell a piece of story. So it will tell you how many actual positive predicted classes you have out of the total positive one. Good when false negative are expensive. So this means if you have the use cases in which your false negative is very expensive, in that case, you can apply the recall. Recall your evaluation matrix. A bad model can have a high recall. This is, I will show you in the next example. Does not penalize the false positive. So perfect recall can be achieved by predicting all positive, because our goal is to predict total positive value, maximum out of the total actual positive. If you look at this example, now my actual value was negative 0, but machine is saying, no, it's a 1. So how did this model do? The true positive value is only 1. If you look at these, this count is only going to be 1. And others, false negative is 0. So what will happen in the recall? 1 divided by 1 plus 0. So this model found all of the positive sample. This is a recall of 100%, right? Because it is saying this is one, this patient, if I connect it again with the cancer example, I'm saying this patient has a cancer. My machine is also saying he has a cancer. So this means I have only the one positive actual value and my machine is also predicting the only one actual value. This is our goal, right? In the recall. But this is not going to work in this use case. It is going to be fail. So this is a bad model. If you have a high recall, then it may be the bad model in this kind of the case. Because if patient does not have a cancer, what will happen? He say, no, he has a cancer. Any questions about the recall? Precision. So after confusion matrix and accuracy recall, we have another method, precision. So what is a precision? Are a predictive positive really positive? So what is the difference between both of them? If you look at them. Here in the recall, we were saying this is the actual value. We were predicting the total positive cases. Here we are trying to know if my machine is predicted this is positive, was it actually positive? So in this case, like we say, if actual input is 1, is my machine is saying 1? If it is actually say 0, my machine is still saying it's a 1. I'm going to like making sure is this 1 in both cases. If not 0, then it is going to be increase the false positive numbers, type 1 error. In this, we need to reduce this type of error. If this is going to be more expensive, in this case, then we need to reduce it. We can connect it with the email example here. If the email is not spam or spam. If my machine, like say, the email is a spam, then machine, if I'm giving the input, this is spam, and my machine is also predicting it's a spam, then this is fine. But if I'm saying this is not spam and my machine is saying, no, it's a spam. So I am going to miss a very or maybe the urgent email. So in this case, we need to take care of false positive numbers. We need to reduce type 1 error. What is the formula? How I can predict the precision percentage? TP divided by TP plus FP. So this is a formula for this one. We also call it positive predictive value. If someone asks you in the interview as well, what is the positive predictive value? We need to explain the precision. Any questions about the precision? Precision, false positive. What are the prompts for this? Minimize false positive rate, as you have seen here. Tells a piece of story. It tells us like in the detail, like how many actual positive classes your machine predicted. Good when false positive are expensive. This is for sure. It again, I will say, depend upon your domain or use case, what you want. Cons. A bad model can have a high precision, does not encourage finding positives. Perfect precision can be achieved by predicting all negative. So if we go to this example again, look at this example. Here it is actual value is 0, it's saying 0. But actual value was 1, it's saying 0, right? So in this case, your precision is 100%, right? And if you look at these value, true positive value is 0, false positive we got 0. If we apply the formula, technically it is undefined because 0 divided by 0. So if you have a high precision model, it is, or if we use here again, connect the over again, same example for the disease, it is going to be a bad model in that case. Any questions about the precision? Okay. F1 score. So these were the precision, recall, accuracy we have learned. Now, we were talking about the how you can like use that. What is the purpose of precision, recall, accuracy? It depends upon the vary to use cases as well, right? And it also depends upon the your class balancing. If you have a balanced data, right? I'm not saying this is for sure. If you have a balanced data, you can directly apply the accuracy. You will get the you will come to know how your model is performing. You need to try all matrices and see the results. And if you have an imbalanced data and sometime you want to balance precision and recall both. This is like both you want to like balance. In this case, we will say it F1 score. This is the formula for the F1 score. 2 multiplied by precision multiplied by recall divided by precision plus recall. So you need to balance both these values here. So this is the F1 score where we need to take care of both values, the type 1 error, type 2 error. Any questions about the F1 score?
So do you want the F1 score to be high or low? What is good and bad?
The F1 score should be your you can say depend upon your type of the class, because when you apply the F1 score, if you have a 2 classes, 3 classes, each class will have its F1 score. If it is near 1, it is good. And if it is less than that, it is between 0 and 1, right? And you will also get the precision and recall values with this one. I will show you. First of all, let's discuss about the prompts of the F1 score. Gives a more complete picture, penalize of both false positive and false negative errors. Hard to interpret, hard to explain, especially to non-data scientists, because it is going to give you the detailed report. Not good for the presentations, this one. So now this is a summary of the classification matrices. Accuracy used when you have a balanced data. As we have discussed, if you have a balanced data like the class A, class B, you want to find out how many predictions were correct, good for non-technical audiences. Recall. Use a recall when you want to evaluate the rate of the false positive. Like you want to reduce this one. For example, good to use with the cases such as a cancer diagnosis, as we have learned in the previous slide. Precision. Use the precision when the cost of the acting on a false positive is really high. Because in the precision, we need to reduce the rate of false positive. Allocating resources, interventions for prisoners who are at a risk for being a refender. So you can, this is the use case of this kind of problem. F1 score, most informative about overall model quality, but is the most difficult to express to a non-technical audience. Any questions so far?
Hey, Ryan, can you explain what you mean by power? I see your comments in the chat. I just want to make sure we weren't missing a concept or a question there.
When you have a study, like for anything, you give a power of the result, and that power is a number that shows the quality of the data with a limited amount of errors. So usually you want a power of a study above 80, and that shows you that you have a good quality set of data without, I don't know, maybe Clint can explain it better. He's a stats teacher.
Yeah, it's non-AP. Power level is like your beta level, I believe, for 1 minus beta. I always kind of forget. I always kind of skip over because it's non-AP and my kids have trouble with it. But yeah, powers is just like one more measurement. It sounds like it's very similar to F1, where your results don't really mean much if you have a low F1 score, kind of like your results wouldn't really mean much if you have a low power level. And so there's ways to raise your power level, but you're usually sacrificing something else with your test. So unless you get a bigger sample size. Yeah, it's more your distributions. I mean,
yeah, so you guys, I see what we're saying. A little more in-depth statistical concept. So, okay, got it.
About balancing the data. So if you have 70% of the data, let's say being dog and 30% being cat, then you're saying this is bad and it makes sort of your model biased because you have a lot more of one versus the other. And then what do you do about it?
Like 70 to 30% is not an imbalanced data. This is quite okay, right? Imbalanced data is like something if you have only like I would say 90 pictures I have for the cat and 10 pictures for the dog. In that case, we can say the model can be biased.
So ideally, you want for each category to have equal number of samples for training?
Not equal numbers of, but it should be little balanced. So like you can, this is for what we are using the classification matrices. So it will help you to evaluate then, depend upon your like the classes.
So what do you do? Do you drop drop some of the data so that they become more equal?
No.
No, don't drop data. In the example of like image regression, there are ways to increase the amount of images you have. There's confusion matrices, and there's altering the data, the images, so they're different images. Like you can flip the image and it creates an entirely different image for the computer to use. But
so Rod, you can use things like SMOTE to be able to balance your data set. There are techniques to be able to balance your data set. There's also, if you have logistic regression, there's an argument that you can use this class balance, and you can tell it to balance your classes, and it'll just with that one line of code, it will balance your classes.
Does it generate synthetic data then?
SMOTE does generate synthetic data. Yes, it does.
Okay, thank you.
Okay.
Okay. So let's move to the next topic, that is multi-class classification matrix. So now we are going to talk about the multi-class classification. So in these, you have a more than 2 classes. There is a no 0 and 1. There is a 0, 1, 2, and maybe we can have more in this. So if you look at this confusion matrix, you can see it is also explaining very well about each class. If you look at these two, the input of the true label is 2, and my machine is able to predict it, the positive cases of this one here 12. And if you look at the here 1, it is going to be predicted only 1. Here 9 cases. So the same with the 0. So it is well explaining well about your classification model. So in this, positive class must be defined to calculate recall, precision, and F1 score. So when you have a multi-class classification, when you apply these, you will get the value for each class differently for recall, precision, and F1 score. False predictions are any prediction other than the true predictions. Can require interpreting matrices on multiple classes to get a complete picture of the model behavior. So how we can do that? This one. So this is the whole using a single your method, you come to know the results of the each class using this classification report. You can use a print statement to print it so it look nice. If you look at these, this is the your classes 0, 1, 2, and these are the average for each metric. If you look at these, and this is the accuracy, this one, and number of observation in each class is this. And if you look at these, this is your 0 class, and your prediction is 100% in case of precision. So this means this is like lowering the false positive cases. This is a recall 100%. This is F1 score is 100%. And if you look at this, what is the accuracy of this one? This is 97%. And in case of 1, it is also giving you the all different accuracy for each classes. Macro average is a case. This is the average of your F1 score. So it is, you can take the average of this one. This will become macro average. And this is generally we use when you have we have a imbalanced data and you don't want to specify the specific classes, then you can use the macro average. This is the weighted average. In the weighted average, this F1 score for each class will be multiplied by these sport numbers and then take the average of this one. So this is the weighted average. Any questions about the classification report?
If you wanted to see which category is it more biased to, which number would tell you that?
More biased, you can look at it, the precision, recall, and F1 score. If you look at these, the F1 score, it is a 95%, right? So it belongs to the first class, right? And 96% to the 2, and 0 towards the 1. If I say the F1 score is very good, it is finding the 0 as a positive, these classes, taking it as a mostly the positive classes, because this is the result which is most coming out of these 3 classes.
Does it mean most of the time this model would find things to be 0?
Not, yeah, we can say the 0, but this means I have trained my machine. My machine will consider the 0 as the positive class. Here we are not talking about positive, negative, because it is a multi-classification. So here I'm considering this category as the positive. Let's say in that case, this is giving the 100%.
Okay.
Confusion matrix, you can write it in the sklearn. You need to import this package matrices import confusion matrix display. Here you can, like, this is over the instance of the model, data set, and then target frames, labels, and you can confusion matrix display dot from predictions passing by test prediction, and display labels. So here is the link is also given if you look into more deeply into the your data detail. Any questions till so far? Okay. So we will move to challenge. Here, in this notebook, you will use the data about the cancer cells to determine whether tissue from a breast biopsy is cancerous or benign. The data set features are various measurement of cells, and the target is whether the cells are from cancer, tumor, or benign one. So in this, what we need to do, we need to import the libraries. This is Panda, NumPy, Matplot, sklearn dataset. So we can load this dataset. And this is for KNN class neighbors. This is for our standard scaling. This is we use to make a pipeline. This is for our train and test split. And this is the all matrices. We will import accuracy score, recall score, precision score. And then F1 score, classification report, confusion matrix, and this is display. So first of all, we will load the data in this. Here we are creating the data frame from the for the data set. And then we are separating the feature names and then the target. If you look at these data set, it will look like this one. So you have a 31 features and 5 rows here. How df.info we use to see the detail of the data set. You have a total entries 569 and you have how many features? 31. So first of all, we will check here, like, is there any duplicate? Is there any missing value or not? I'm using isNA.sum for checking the missing value, and this is for duplicate check. If you look at these, there is a no missing data. There is a no duplicate. So in this, we need to detect the patient has that type of cancer, benign or not. The result dot value counts here. We are checking the balancing of the class. That is 1 belongs to 62% and this is 37%. Now we will split the data using the train and test split. First of all, we will separate the features. We will drop the target variable from the X features and put it into the Y variable. Here we are declaring the variables X train, X test, Y train, Y test, and then passing XY, random state is equals to 42. Here is a challenge. You can start with this one. Model the data, use a pipeline to scale and fit a model and make a prediction. So you need to first make a pipeline to scale the data set and then make a predictions. Create a pipeline with standard scaler and KNN classifier. Fit the pipeline on your training data and then save the model's prediction on X train, X test in variables. So these are steps you need to follow to model the data. After that, you will do the model evaluation. Use classification report as we have seen. How it look like for the multiple class. Accuracy, precision, recall, F1 score, both on training and testing data. Discuss, does your model have a high variance or high bias? Plot a confusion matrix of testing data to get complete picture. Notice there are a few ways to use confusion matrix display. Check the documentation by using this link. You can check the documentation. Now you need to also discuss how is your model doing? Which class is better at predicting? How many false positive mistake is it making? How many false negative by confusion matrix? Considering the problem this model is solving, which kind of error is worse? False positive or false negative? You need to tell. In the bonus, you can try to tune your model or try other models to get the best scores. I'm going to open the breakout rooms. Like after the live class hours, if you want, you can stay. And if you want to go, you can also go. I will stop sharing.